very differently. So this is one of the example where you will be seeing the grade distribution of the students, the grades and the frequency of the students. You can see this is a simple bar graph, and you can see the test score distribution by implementing or plotting a Gaussian curve on this. So when you plot a Gaussian curve on the data, you can see whether it is following normal distribution or not. So in this particular data visualization, you can see that there is a huge skewness, or I can say most of the graph has been towards the right side. So right skewness, the people with the test percentage score, the people with the 96 to 100 are very low. Okay, but most of the people are scoring around 20 to 60 percentile. So the distribution is towards the right side. So right skew is happening in the data distribution. And similarly, the same thing if you observe by using a IQR style distribution, you can see this is class A and class B between the classes. You can observe over here. So this is the point where one of the student may be getting very low marks, and in class B one student is getting very high marks. So these data points can be easily visualized by using interquartile range distributions. So coming to the independent and dependent variables. So here this plays independent and dependent variables a major role in case of experimental results. So when we do the IC50 value calculation for any set of molecules, okay, you will be taking concentration of the drug, okay, and different molecular weights, then similarly different log p values, okay. So different parameters will be affecting the IC50 value of the molecule. So you will be having independent variables and dependent variables. So independent variables are the one which will be called as a predictor or explanatory variable. So this independent variable will be directly affecting the activity of the molecule. So always independent variables will be drawn in a horizontal line, and the dependent variables where the activity will be seeing will be drawn in the y-axis. Okay. So whenever you will be dealing with the large data, you have to identify what is the dependent variable and what are the independent variables. Is there only one dependent variable, or multiple independent variables, one dependent variable? So you have to segregate your data into dependent and independent variables. If you identify wrongly the dependent variable, your calculations becomes wrong. So for example, when I am dealing with the diabetic data condition, okay, what is my dependent variable here? Whether the patient is diabetic or non-diabetic. But if I consider the glucose levels as a dependent variable, then my whole calculation becomes wrong, because glucose levels will be again depending on the patient conditions, and what is his height, weight, and what is his normal metabolism levels. So all these things will be affecting glucose levels, and these glucose levels, based upon that, you are going to segregate whether the patient is diabetic or non-diabetic. So you have to identify exactly what is your dependent variable and what are the independent variable. So let me explain here one example. When we are considering the diabetic patient's data, okay, my dependent variable is whether patient is diabetic or non-diabetic. But you have a independent variables like the patient name, patient ID, age, height, weight, glucose levels. So in this case, I cannot consider all the 6 as a independent variable, because patient ID cannot be a parameter to segregate as a diabetic or non-diabetic, and patient name also not a variable, and age is one of the factor you can consider as an independent variable, and height, weight, and calculating the BMI from that. So how to identify dependent and independent variable? So here the domain expertise is needed. So if you are a pharma person, you can easily understand what are the parameters which are affecting the diabetic condition. If you are a computer science person without having any health sector data, you may be considering that all variables are a independent variables. Okay, here domain expertise plays a major role to identify independent and dependent variables. So I can ignore patient name, patient ID, so that I can reduce the calculation time. I can consider only the height, weight, glucose levels, and one more extra BMI calculation. From height, weight, you can calculate BMI, and that BMI can also become a one independent variable, and the glucose levels. So these four can become an independent variable to decide whether the patient is diabetic or non-diabetic. Hope I cleared your question. So you should know what are the experiments people have done to bring that data, and what is the impact of each column. Like if you are doing a formulation related experiment, okay, you may be getting data related to the tablet weight, okay, thickness, hardness, and the solubility, and then you will be getting dissolution profile or disintegration profile. So whether all these will be affecting the bioavailability of the molecule, or only the solubility is very important factor which will be directly impacting the bioavailability of the molecule. So depending upon the experiment and the data which you have in the columns, you have to decide which is the independent variable affecting the bioavailability of the tablet or molecule. So there is no automatic process to identify independent and dependent variable. You have to uh, select based upon your domain knowledge. Sometimes I feel that BMI is very important for the diabetic or non-diabetic condition, because it is calculating from the height and weight. So BMI is indirectly proportional to the ratios of height and weight. So you may be considering that I don't want BMI, I want only the height and weight directly impacting the diabetic condition. So it depends upon person to person perception which parameters he can keep. Because of that he can get a good conclusions from the data. Next is visualizing the relationships. So if you want to understand the relationship between the dependent and independent variables, we will be using 2D analysis. So most of us, we have already familiar with the such type of 2D analysis. You will be having x-axis concentration and y-axis absorbance. We try to plot a graph and try to see whether it is following the uh, best fit line curve or not. So such type of data is easy to understand. But if you want to quantify that, so what is the percentage of impact of the particular data point? You can use a bubble chart which is called as pseudo 3D analysis. So based upon the size of your bubble, you can say that how much contribution that particular data point is giving to the whole data. Okay, this is one of the feature which will be possible in case of visualization relationships. And if you want to understand the association between the data points, okay, we will be using the Pearson correlation coefficient. We are familiarized with that R value. So we will be having a R value. Based upon the R value, we try to say that the correlation between the data points is strong or not. So whenever you have a scattered data, okay, then you can say that this data doesn't have any relationship. So one may be until unless you segregate it as a two different patterns, okay, that is different story. But by seeing this graph which is scattered, you say that there is no correlation between the data points. Randomly these data points are behaving. But if you see a perfect positive side, like from best fit line, if it is forming from and originating from the zero and it is increasing, depending upon the concentration, the absorbance is increasing. You can see that there is a perfect positiveness is present. So if I change the x-axis concentration wise, the absorbance also increasing, and this is called as a perfectly positive correlation. And you will be having a perfectly negative correlation also. The data activity may be decreasing in a negative direction, that is called as a perfectly negative correlation. So if you want to interpret the results of this R value, this is the breakdown of the R values. If it is less than 0.8 to between less than 1, then you call it as a strong relationship. Between 0.4 to 0.8, you call it as a moderate relationship. 0 to 4, you call it as a weak relationship. So when we do the graphs, you will be getting R and R square values. Based upon that, we say that by seeing the visualization also, you can say there is a strong relationship or moderate relationship, but by the values also you can correlate. So this is the formula how the R can be calculated. So I am not going in depth because this is self-explanatory from where we are getting the R values. And if you want to recognize how the based upon the pattern, as I told you, once you have a data points with you, you understood what the data is giving, and from that you are going to predict if new data comes where it will fit. Like we most of us, we have already seen, you will be plotting concentration versus absorbance and you will get a best fit line, and after that unknown sample will be given to the students and they will find out the absorbance and they try to put that absorbance value in the best fit line and interpolate towards the x-axis to find out the concentration. That is called as prediction. So but when we do in a laboratory level, there are only 4 to 5 data points will be present. But when you collect data from the big resources like collecting the EMBL data to find out the descriptors or to find out the absorption properties, distribution properties. So when you have a large set of data, you will be using machine learning models to predict the new values from the test value training values. So this is how the prediction line will be uh, identified. So initially you will be having x-axis, these are the data points which you can see here, best fit line forming data points. So this is the point where exactly the molecule is present, initially the concentration versus absorbance if you take, and but the predicted value here you try to calculate difference between the actual value and the predicted value. Based upon that, you will be trying to get the various parameters like root mean square deviation, mean square error, root mean square error, and error values. So this is the mathematical equation to construct best fit line y is equal to mx plus c. Then we will be calculating slope value by the formula this one and the intercept value. So from these values we try to analyze the data to give a y is equal to mx plus c equation, and this equation will be used as a predictive model. Whenever you have a new x value, you are going to put it over here and find out the y value. This is about a univariate and bivariate analysis. So let me go back to the slide which I told you. I'll come again. Yeah. So when we do the exploratory data analysis, we will be using univariate analysis, bivariate analysis, and we use distribution, histograms, box plot to do the univariate analysis. And we will be trying to calculate mean, median, mode. For bivariate analysis, we will be using scatter plots to understand how the data has been distributed and the correlation, whether it is a positive correlation or negative correlation, is there any no correlation between the data points. You can use crosstabs and heat maps if you have multiple variables. Like instead of 2 variables, you will be having 7 to 8 variables. You want to understand the correlation between those 7 variables. You can use heat maps for that one, and you will be using a segmentation analysis where you will be doing group by analysis, cohort analysis, pivot tables. All these will be used in case of clinical trial grouping and clinical trial data analysis. And anomaly hunt will be nothing but we are going to find out the outliers. As I told you, by using IQR method you can find out the outliers, and the time trends you will be using if it is a if you are working with a date share market, you will be having a data with respect to the timeline. So today 24 hours, what is the share price? Yesterday, what is the share price? Minute to minute, how it is decreasing or increasing? So you will be using different types of trend calculations in case of share market data, time trends. Okay. Similarly, you will be using Simpson paradox and Luckring variables. These are the higher end anomaly hunt calculations. So this is about the various statistics. So to understand here, we will be using univariate analysis, which will be describing what is there in your data. And when you do the bivariate analysis, it will explain you, or you can find out new variable which is affecting your data points or the total activity. And from here, by using regression modeling, you try to understand how this mathematical model can be used to forecast the new data with a confidence of mathematical correlation. So for data visualization, as I already told you, when you want to compare the data, you will be using bar and column graphs. Trend overview, you will be using line area. Part to whole pie charts will be used and to quantify the data. For distribution, you will be using histograms. Relationship, you will be using scatter plots, and geography, you will be using dot map or flow type of chart types. So the key takeaways from this particular session is that we have seen like what is data, from where you have to collect the data, how to prepare the data, and how to develop a model and how to visualize a model. So here the question is, if you have data in your hand, you should not directly jump into the data analysis. You have to first understand what data I have collected, what I am going to look into that data, what are the conclusions I am going to retrieve from that data. So you should try to start with the question, not with the data. Okay. Next is, if it is dirty data, how to prepare it as a clean data. So always if you use the data which is not in a good condition, will result into a wrong calculations. And for every chart you make, you have to give a conclusion or a decision. It's not simply drawing the graphs and getting the pictures. You have to understand what is giving the chart, what is the inference the chart is giving to me. And you have to correlate the needs as a casual story. So if statistics you are getting like mean, median, or R value, correlation coefficient, or accuracy value or precision value, you have to understand how these values will be comparable with the data. Okay. And how these values I can convert into a significant answers for the query. And also insight must be drive action. So you try to find some data or some statistics instead of what you are looking for. So don't throw the data and don't throw the calculation. You try to understand or correlate or bring some conclusions from the statistics which you have received from the calculations. And next most important is culture beats tool. So if you are having a tool, we feel that we can do anything, but without question you cannot do anything. So always we need a person who questions our calculations. If somebody questioning your calculation, then only you can go deep into that calculations and you can say that this is what I did and I got this answer. These are important for the particular query. So these are the key takeaways from this particular session. If you have any doubt, feel free to ask the questions.
Thank you,
And
Malika ma'am, for your
and
wonderful session. It's very informative, ma'am.
thank
We
you.
have gained more knowledge on the data analysis, ma'am. Dear participants, thank you for participating in the FTP. And we have come to the QA session. If you have any doubts, please post it in the chat groups.
Yeah, you can put it in a chat box or you can directly ask the question by unmuting yourself. And in the coming session, we are going to see exactly how to collect the data and how to do analysis and missing values, duplicate values by using Python.
Any questions from the participants?
So most of us as a pharma faculty, we feel that data is not like important for us. We just directly collect the data and we try to analyze simple data. But once you start collecting the data from public resources, clinicaltrial.in, so you can understand how dirty the data is and how to analyze that data into a meaningful data.
Ma'am, participants are asking for the PPT, ma'am.
Okay, okay. I will share with the host and you can share it to them. Okay.
Yes, ma'am. Thank you. Ma'am, I have a question, ma'am.
Yeah.
Ma'am, you told that in bivariate analysis, we
Mm-hmm.
can use heat maps.
Yes.
Ma'am, in our pharmacy, can be, uh, what type of data can be used for the heat map?
Yeah, any type of data. For example, if I say you are having multiple variables, as I told you, formulation data, if you see, for that
Yes,
particular formulation, you will be having hardness, dissolution profile, dissolution rate, or disintegration rate, or solubility rate, and
yes.
everything is affecting the bioavailability. If you want to understand correlation between these five parameters also, you can generate heat map. That we are going to see in today's afternoon session, the heat map generation with pharmacovigilance data.
Yeah, okay. Thank you,
So
ma'am.
if you are having multiple variables, you can generate heat map to know what is the correlation between
Correlation.
these
Yes, ma'am.
different variables.
Thank you, ma'am, for your explanation. Okay, we will, following session will be in the afternoon at 3 p.m.
Okay.
Thank you, participants, for participating in the FTP. Thank you, madam.
Thank you. Thank you for giving me this opportunity.